Hi everyone, welcome back to the channel. Today we are going to break down one of the most powerful algorithms in machine learning, support vector machines or SVM for short. Whether you are a student, a data scientist or just curious about how machines classify things, this video will give you a crystal clear understanding of how SVM works. So, what is SVM? SVM is a supervised learning algorithm, meaning it learns from labeled data. It is mostly used for classification tasks but can also handle regression. So, the main idea behind SVM is SVM tries to find the best possible boundary or hyperplane that separates different classes in your data. What is hyperplane? A hyperplane is just a fancy word for the decision boundary that separates classes. In two dimension, it is a line. In three dimension, it is a plane. And in higher dimension, it is called hyperplane. SVM aims to find the one that not only separates the data but does so with the maximum margin. Now, what is a margin? The margin is the distance between the decision boundary and the closest point from each class. These closest points are called support vectors. SVM tries to maximize the margin because a wider margin usually means better generalization to new unseen data. Next, support vectors. Support vectors are the data points lying closest to the hyperplane. They are critical because the position of the hyperplane depends entirely on them. If you remove a support vector, the decision boundary can change dramatically. If your data can be separated by a straight line, you can use a linear SVM. But in real life, data is not always that clean. That's when we use non-linear SVMs and the kernel trick to project data into higher dimensions where it becomes linearly separable. Now, what is kernel trick? The kernel trick is what makes SVM truly powerful. It transforms your data into higher dimensional space without explicitly calculating the transformation. Popular kernel includes the linear kernel, polynomial kernel, and the RBF Gaussian kernel. Now let's talk about how SVM works. Imagine we are classifying cat versus dog. Feed the SVM features like ear size, tail length, and fur pattern. The algorithm finds a boundary that separates cats from dogs in feature space. When new data comes in, it, it is classified based on which side of the boundary it falls on. If it falls on the cat side, then it will classify it as cat or vice versa. Now let's talk about pros and cons of SVM. SVM is great for high dimensional problems and works well when there is a clear separation between classes. However, it can be slow on large data sets and performance depends a lot on choosing the right kernel. Also, it is sensitive to noisy data. So, to wrap it up, SVM finds the best possible boundary with the largest margin, uses support vectors to define that boundary, and leverages the kernel trick for nonlinear data. It is a powerful algorithm to keep in your machine learning toolkit. Thank you so much for watching this video. If you found this video helpful, make sure to like, share, and subscribe.